So this is for forces in a circular motion, standard take 4. And in this problem, we have Alexis who wants to turn off the freeway. It gives us the radius of the curve, which is 35 meters. It gives us the mass of her car, which is 1,240 kilograms, and it gives us her velocity as she's exiting, which is 19 meters per second. So in this problem, it asks us to find the acceleration, the net force of the car, and the minimum value of the coefficient of friction to keep her on the road. So by finding the coefficient, we can actually determine if she was going that speed, would she be able to stay on the road. So first we're going to take our acceleration formula, which is v squared over r. So it already gives us our velocity, which is 19 meters per second. So we're going to square that and divide that by the radius, which is 35 meters, which is going to give us an acceleration of her car at 10.31 meters per second squared. Now we're going to draw our force body diagram. So we have her car, and we know that the two main forces are the normal force going up, which is perpendicular, and mg. So then we also have the force of friction, which is going towards the inside of the circle. Well, we know that the normal force is going to be equal to mg. So now we're going to use that to find the net force. Well, using the equation F net equals mass times acceleration, we also know that our F net is going to be equal to the force of friction. So we can determine that the force of friction equals ma. Well, if we're going to use the force of friction formula, we know that's the coefficient of friction times the normal force. So we can go ahead and set ma, so mass times acceleration, equals the coefficient of friction times the normal force. Well, we already can determine that the normal force is mg because we know that the normal force equals mg. So now we have our new equation, which is mass times acceleration equals the coefficient of friction times mg. When we divide by m, we get acceleration equals the coefficient times gravity. Well, we already found our acceleration in the first part, so we're going to divide that by 9.8 meters per second squared, which is going to give us a coefficient of friction of 1.05. Now, because this is such a large number for the coefficient of friction, we can determine that if she's going 19 meters per second, she's probably not going to be able to stay on the road at that speed.